Hey everyone, so this video is going to go through the steps to balance a redox reaction in basic conditions. The way I tend to teach it is you do the exact same way that you would do with it being an acidic condition, and then you do one last step at the end that changes it over to being basic by adding OH- to the system. If you have other ways of doing it that work for you, great. This seems to be a very consistent way for many students because it's one way for both conditions essentially. So it's just easier to remember in the long run. But let's go by the assumption that it's acidic for practically the entire example until the end. So the first thing we need to do with this reaction is split it into two half reactions. So we have the example is silver and your zinc ion transforming into silver oxide and your zinc solid. So your half reactions need to be essentially kind of pulling out the atoms or the species that are similar, so or at least have the same atoms in them. So I see a solid silver transforming to an oxide for one of the half reactions. Let's put a line down the middle to separate visually. The other half reaction I see is a zinc transforming into its solid species. Okay, so at this point, you've split up the two half reactions by just noticing the similar species, okay? The oxygens, the hydrogens that might be in the reaction will just kind of come along for the ride for a little bit. Okay, so on let's just do the left-hand side first, the silver species. What do? Oh, I forgot a 2 there. Good call, Kelly. You need to balance the atoms that are not oxygen or hydrogen, right? That is the first step. So I noticed that the silver on the right-hand side had 2, so we need to put a 2 out front, okay? That's the first step. Second step is balancing your oxygens by adding essentially water to the system. Okay, so I've noticed that there's 1 oxygen on the right hand side, so I'm going to add 1 water on the left hand side because I'm just balancing the oxygens. Okay, but what you've done is you've added hydrogens to the system. And how do you add hydrogens to balance that out? You add it in the form of H+. Now, how many did we actually add? We added 2. So on the right hand side, we need to add 2H+. Okay, so that takes care of the atoms that are not oxygen and hydrogen, and then the oxygens, and then finally the hydrogens. And your last step would be to deal with the charge. So look on the left hand side of this reaction. These are all neutral species, so there's essentially a 0 net charge. But on the right hand side, this right here contributes +1 per hydrogen, right? So we have a total of a +2 charge on this right hand side. Therefore, if we're adding electrons to balance the charge out, we need to go to the more positive side. And what we do is we're going to add +2 electrons to the right hand side, because that means that essentially balances the entire right hand side to be neutral and it matches the left hand side. Okay, so this would be where we would stop for now, and then we're going to transfer over to the right hand side for the zinc species. So zinc on its own is balanced. There's 1 in each on the reactant side and the product side, so we can essentially check that off the list. Are there any oxygens to balance? I see none, so we don't have to deal with adding water. Do we need to add hydrogens? No, because there are no hydrogens to balance on either side. And then finally, the last step would be electrons. Okay, so there is a charge, and I'm noticing there is a +2 charge here, and this is a neutral species, so it'll be a 0. So in that specific case, what are we going to do? We are going to add 2 electrons to the more positive side. Okay, so now this whole left-hand side is a 0 charge and matches the right-hand side, which is a 0 charge. Great. So the next thing we need to do is combine these species, these half reactions into one. Okay, So I'm going to go back to maybe black for this. So we are going to add all of the left-hand side together. So this left-hand side plus that left-hand side first. And it really doesn't matter what order you put things in. So I'm just going to go left to right for ease. So we have a water plus 2 silver solids. Cool. And then we grab this zinc 2 plus 2 electrons. Great. Now that is the entire left-hand side if we're combining, and we're going to add it, or put down the products by adding a silver oxide species plus 2 protons plus 2 electrons plus your zinc solid. Great. So that would be once you've added both your half reactions back together. And what you can do is you can say, well, mathematically, if there's 2 electrons on the right and there's 2 electrons on the left, they just cancel. Okay, go back to your algebra skills. If you have an x on the left and x on the right of an equation, you can just subtract them out. Okay, now this would be the answer after you cancel the electrons for acidic conditions. Okay, so this would be acidic. You'd stop here. But we need to answer the question if it were in basic conditions. So what you do is you add OH minus to the solution. But you need to add it to wherever you see the protons. Okay? However many protons there are, you add that many OH minuses. And what it turns into, so you'd add 2. Remember, an OH minus and an H plus becomes water. But wherever you added something on the right hand, on one side of the reaction, you have to add it to the other. Okay, so we're almost done. So we've added OH minus on the right, and that essentially transforms itself into just being 2 water. But look over here, this right here, there's already a water here. What do we do with that? We're going to cancel that one out entirely and reduce this down to 1 water. Okay, so we can do our final expression. On the left hand side we have 2 silver solids plus a zinc 2 plus 2 OH minus gives us oxide plus 1 water plus your zinc solid. Okay, so this right here would be your answer in basic conditions, because all you needed to do was add the OH minus at the end to get a complete, basic reaction. But just remember, when you add it to the right hand side or wherever you're adding it, you need to add it to the other side to make sure that you're keeping the entire system balanced. Okay, so hopefully this is helpful, and I would encourage you to practice many more.